So let's see what the fourth problem states. The fourth problem states here, the shadow of a vertical tower on a level ground increases by 10 meter. Okay, when the altitude of the sun changes from 45 degree to 30 degree. Find the height of the tower correct to 2 decimal places. So you have a vertical tower first of all. Okay, let's say this is your vertical tower. Okay, and let's say this is your ground level. Okay, this is your 90-degree angle, right? Now in this vertical tower, the shadow of this tower increases by 10 meters when the altitude of the sun changes. So this is the place where the light is coming from. Okay, the sun may be, let's say, somewhere over here. Okay, you don't know where the position of the sun is, but you definitely know that the source of the light is from here. Let's call this point A. So A is the source of the light. Okay, now the altitude of the sun changes from 45 degree to 30 degree. What does the altitude of the sun means? That means the sun, let's say, is moving in this direction towards sunset. Okay, and first of all, when the sun was in its initial position, the shadow was here. Okay, this was the length of the shadow initially. Okay, this is your initial length of the shadow. Okay, so the altitude of the sun changes from 45 degree to 30 degree. So here the altitude of the sun here in this case was 45 degree, right? And now as the sun is moving in this direction, the shadow elongates, right? So let's say the shadow elongates from this position, let's say, to this position. This is the new length, or let's say elongated length of the shadow. Okay, this is the elongated length of the shadow. And what is the altitude change from 45 degrees to 30 degrees? Okay, so now if you see, the shadow elongates by what length? So from this length to this length, that means the shadow elongates by a length of, they have given you the shadow elongates by a length of 10 meters, right? So this is what the entire diagram is. Now this looks like your type 1 diagram, which I had discussed in the beginning, right? And question here is find the height of the tower correct to 2 decimal places. So let's call this point B. Let's call this point D, and let's call this point C. We have to find out the length of the tower, or the height of the tower, which is AB. Just as we had done in your type 1 figures, we'll find out exactly in that. Okay, let's say the height of the tower is H, and let's say this one is X. Okay, so therefore we are going to use tan in that triangle ADB. So in triangle ADB, tan 45 degree is equal to AB by DB. Tan 45 is 1, AB is H, and DB is X. So you're getting H is equal to X. Call this equation number 1. Okay, now we'll apply tan 30 in triangle ACB, or let's say ABC. In triangle ABC, tan 30 is equal to, this time it is AB by CB. So tan 30 is 1 by root 3, and AB is H. And what is the length of DB? If you see DB, AB by CB, the entire length. What is CB? CB is this length, X plus 10. Right? So you cross multiply. X plus 10 is equal to H root 3. This is your second equation. Now these two are simultaneous equations, 1 and 2. We need to solve simultaneous equation 1 and 2 and find out the value of h, right? Because we need to find out the height of the tower. So what do I do is, so from 1, putting x is equal to h in 2, we get h plus 10 is equal to h root 3, right? That means 10 is equal to h root 3 minus h. That means 10 is equal to, now you take h common, you get root 3 minus 1. Now you can divide both sides by root 3 minus 1 to get 10 by root 3 minus 1 is equal to h. That means you are getting h is equal to 10 by root 3 minus 1. But they have asked you to find out the height of the tower correct to 2 decimal places. That means this here I have, if you see, the denominator here is irrational. So we need to rationalize the denominator because we want to find out the exact value in decimals. So we will multiply the numerator and denominator by the rationalizing factor. That is, we are going to rationalize the denominator of this fraction. Okay. So this will give you 10 times root 3 plus 1 by root 3 square minus 1 square, which will give you 10 times root 3 plus 1 divided by 3 minus 1. So will give you 10 times root 3 plus 1 by 2. Now you can cancel here, or better still, even if you don't cancel, you can do it directly also. You can substitute the value of root 3 as 1.732 plus 1 divided by 2. Now the advantage of not cancelling here is because we have a 10 in the numerator and we can multiply easily any number, any decimal number with 10, right? So you get 10 into 2.732 divided by 2. Now you can multiply 2.732 with 10 to get 27.32 divided by 2. Now if you divide this, you will get 13.66 and so on, this 13.66, right? And they have asked you the answer correct to 2 decimal places. So we have got the answer correct to 2 decimal places. If they had asked you the answer correct to the nearest whole number, then what would your answer have been? Your answer would have been 14. This is meters, right? 14 meters. Correct to the nearest whole number. Right? So this is how we work out this problem. Okay. So that finishes this problem. We'll now see the next question. Now, there's one thing which you must observe here. Before I start with the next question, I would just like to mention this. Whenever you see the type 1 figure, okay, always try to remember that this angle here, if you see this point C is distant from the point B, and this point D is closer to B, right? So if you see, B to C is the higher distance, and you see this is the lower angle. That means out of 30 and 45, this is the lower angle, right? And if you see distance between B and D is lower distance, and you see the angle here is the higher angle. Okay, higher angle, right? So always remember that this angle, the distant angle from B, will always be the lower angle. If you remember it this way, it will be convenient later on for you to cross check with the when you're drawing the diagrams. Okay, look at number 5. Question is, a man observes the angle of elevation of the top of a building to be 30 degrees. So they are talking about the angle of elevation of a building. That means the top of a building. That means the observer is at the ground level. That is, observer is at a lower position. The object is at a higher position. And what is the object here? The top of the building is the object. Okay. So let's say this is your building. And this is your ground level. Okay. Let's call this building as A. This is the top of the building A. And the foot of the building is B. Okay. So man observes the angle of elevation of the top of a building to be 30 degrees. So let's say the man is standing here at C. Okay. And he is observing from this position, from a lower position, because this is the observer. Okay. And this is the object, because they are talking about angle of elevation. So if we join this, this is the line of sight. And the angle of elevation is given to be 30 degrees. So this angle made with the horizontal is 30 degrees. Okay. He walks towards it in a horizontal line through its base. That means now the man at C starts walking towards the base of the tower. Okay. In this direction. On covering 60 meters, the angle of elevation changes to 60 degrees. Okay. So on covering 60 meters. So let's say if the man starts walking in this direction, let's say after walking in this direction, he reaches a point here. Let's say a point D, which is 60-meter distance that is covered. So this distance that he has covered in this direction is 60 meters. Now in this direction, the angle of elevation changes to 60 degrees. So now from here, when he's observing the top of the tower, the angle of elevation is 60 degrees. Okay. Question is, find the height of the building correct to the nearest meter. You need to find out this height, AB. Okay. So how do you proceed to find out this height? If I take this height of the building as H, and if I take this length dB as X, so I say let AB, let the height of the building be H, and this the length dB is equal to X. So therefore AB must be equal to H, right? Now we'll use tan 60 in triangle ABD. So in triangle ABD, tan 60 is AB by DB. The value of tan 60 is √3. AB we have taken as H, DB the length is X, right? So we are getting here H is equal to X √3. Let's call this 1, because we'll get two simultaneous equations which we'll be requiring to solve. Okay, so in triangle ABD we have used. Next, what triangle shall we use? We shall use the 30-degree angle in triangle ABC. Let's write in triangle ABC, tan 30 degree is equal to AB by CB. And the value of tan 30 is √3, 1 by √3. AB is H, and CB, if you see the entire length, is this length X plus 60, right? So this will give us our second equation. We get X plus 60 is equal to H √3. Call this equation number 2. Now we are going to solve equation numbers 1 and 2 simultaneously, and we are going to find out the height of the building, right? So height of the building means we are going to find out this h here. Okay. So if we want to find out x between these two, what are we going to substitute? We are going to remove x from these two, right? So from 1, what is the h is equal to x root 3. That means we are going to find out x in terms of h by root 3, right? Putting this value into, we get h is x is h by root 3 plus 60 is equal to h root 3, right? Now this is we have eliminated x that between 1 and 2. So we have equation only in h because we want to find out h. So this is a simple equation which we can solve. So h by root 3 minus h root 3, or let's say the other way around. Let's keep 60 on the right hand side. We have 60 is equal to h root 3 minus h by root 3, right? So that means you get 60 is equal to, now you can take the LCM here, root 3, h root 3 into root 3 minus h. So you get 60 is equal to 3h minus h by root 3. And that means you get 60 is equal to 2h by root 3. Now you cross multiply, you get 60 root 3 is equal to 2h. Means you get 2h is equal to 60 root 3. Now you can find out the value of h by dividing both sides by 2. H is equal to 60 root 3 divided by 2. They're getting 30 root 3. Now because we need to find out the answer correct to the nearest meter, we shall convert root 3 to a decimal. So 30 into 1.732. Okay. Now how do I multiply this? See, 30 can be written as 3 into 10 into 1.732. Now if I multiply this 10 with 1.732, we are going to get 3 into 17.32, right? And 3 into 17.32 is going to give me 51.96 meters. But they have asked you the answer correct to the nearest meter. So 51.96 is greater than 51.5. So it can be written as 52 meters correct to the nearest meter. Right? That should be your answer. Fine. Let's move to the next question. Look at this. From the top of a church spire. Now, what do you mean by spire? Spire is, a dome, let's say. Okay. Religious places, all religious places have some sort of domes. So that is what. So from the top of a church spire, 96 meters high. Okay, so you have church spire here, which is, let's call this church spire AB. Let's draw the ground level. This is your ground level, right? So from the top, this is the top of the church spire. And this church spire is what is the height of this? 96 meters. The angle of depression of two vehicles on a road at the same level as the base of the spire and on the same side. So two vehicles, this is the horizontal here. So you have a road along this direction or this direction, even here, right? So which are the opposite sides? These are the opposite sides of the spire. So now you have vehicles on the same side and on the same level. So they are both on the definitely same level, means on the ground level, right? So on the same side means suppose you have one vehicle here and you have another vehicle, let's say here. Let's call this point C and this point D. So you have two vehicles, one at C and the other at D. Okay. The angle of depression, that means now because they have given you the angle of depression, that means the observer is at a higher position and this is an object, right? And this is another object, right? So let's draw his line of sight. So from the top of the tower, okay, let's read the full question. At the angle of depression of two vehicles on a road at the same level as the base of the spire and on the same side, C and D are on the base of the tower and also on the same side, definitely you can see, of it are x degree and y degree, where tan x degree is 1/4, tan y degree is 1/7. Okay, so x degree and y degree are the angles of depression. So here you see this is one line of sight, this is the other line of sight. Now these two lines of sight, what is the angle that they make with the horizontal? Let's draw a horizontal here. They make an angle of x degree and y degree. Fine. So let's say this is the this is the x degree angle here, and this is the y degree angle here, right? So let's, if this is x, this must be x also, alternate angles, and this one must also be y, right? So given here, tan x degree is equal to 1/4 and tan y degree is equal to 1/7, right? Now which one is the greater angle? Um, if you see, tan x degree is 1/4, right? And tan y degree is 1/7. So here tan x degree is greater than tan y degree, right? That means x degree is greater than y degree, right? So is x degree in my diagram, is x degree greater than y degree? Yes, because you see this is the closer angle nearer to B, right? This is the nearer to B. So this must be the higher angle, as I told you that rule, and this must be the lower angle, right? So is y the lower angle? Yes, x degree is greater than y degree. So this, we have labeled it correctly. So that is what it means by giving tan x degree is equal to 1/4 and tan y degree is equal to 1/7. Now they have asked you to calculate the distance between the vehicles. Now what do you mean by the distance between the vehicles? Distance between the vehicles simply means C and D are the vehicles, position of the vehicles. That means this is the distance that you need to calculate. Okay. So let's see how to calculate this distance. First of all, we'll consider the x degree angle in triangle ABD. So in triangle ABD, tan x degree is equal to AB by DB. Tan x degree, what is the value given? 1/4. So let's directly put the value. 1/4 is equal to AB. The length of AB is the height of the church spire, which is 96, divided by DB. We'll find out DB. Okay. So that, what is the length of DB here? We cross multiply. We get DB is equal to 96 into 4, which is equal to 384 meters. Right? So you have got this length. How much is this length? 384 meters. We'll now proceed to find out the length CB. Let's see how much is CB. So we'll use the triangle ABC, y degree angle. So in triangle ABC, tan y degree is equal to AB. By this time the base is CB, right? Tan y degree, the value given is 1/7. So let's put 1/7 is equal to, the value of AB is 96 and we need to find out the value of CB. So here now if we cross multiply, we get CB is equal to 96 into 7. So you get 672 meters. So this entire length here, we have got 672 meters. So what is the length of this CD here? Hence, distance between the vehicles. CD is equal to the length CB we have found above minus DB. CB we have found as 672 minus DB we have found as 384. We get 288 meters. And that is the required distance between the vehicles. Okay, fine. So I'll stop here.